In some cases, analytical chemists are given an unknown solutions and they are asked to identify the substances present in this solution. However, in most of these cases, the solution will be a mixture of substances and not a pure substance. So, before identifying the substances present in this mixture, they will have to first separate the components of this mixture, and as we have said before, because there are no chemical bonds between atoms and substances in a mixture, it will be relatively easy to separate the components of a mixture using physical means. The physical techniques available are filtration, crystallization, distillation, and chromatography. For the distillation technique, there are two types. The first one is called simple distillation, while the second one is fractional distillation. So in this section, we will describe in details the first three techniques, which are filtration, crystallization, and simple distillation, while in the next section, we will discuss the remaining two, which are fractional distillation and chromatography. These separating techniques rely on differences of the physical properties of the substances in a mixture, such as solubilities and boiling points. We will start with the first one, which is filtration. So, when you have substances that are insoluble in a particular solvent and others that are soluble in the same solvent, you will use this technique. The simplest example in which you will use filtration is separating a mixture of sand, salt, which is NaCl, and water. So let's take a look now at the apparatus of the filtration technique. In this beaker, you will have the mixture, which is the liquid or the solvent, and the insoluble solid. So you will pour them into a funnel, and in the funnel you will place the filter paper. So the solid will remain in the filter paper while the solvent will be collected in this flask, and it is filtered now. So in the case of separating a mixture of sand, salt, and water, the sand, which is the insoluble solid, will be collected on this filter paper and it's called the residue. And after collecting it, you will wash this sand with distilled water to remove any salt solution left on it. And then this sand is dried in a warm oven to evaporate any water off, and then you will have pure dry sand. In this beaker, you will collect the liquid, which is water and salt, and this is called the filtrate. What about crystallization? For example, you are interested in collecting pure salt from the salt solution following filtration. So actually you want to separate NaCl from the filtrate. So to do so, you'll have to evaporate water from NaCl solution through heating it in an evaporating dish on a water bath. So this is a gentler way of heating than heating the evaporating dish directly. You will stop heating when the solution is at the point of crystallization. And of course, you will ask yourselves now how to detect the point of crystallization. So, you will know when to stop heating when small crystals first appear around the edge of the solution, or when crystals appear on a drop of solution extracted from the dish with a glass rod. The rest of water in the solution is left to evaporate off at room temperature to get a good sample of NaCl crystals. You can also use a petri dish like the one shown here in the final step, which means when you will leave the water to evaporate at room temperature, because this provides a large surface area for the water to evaporate from. So, crystallization allows you to separate a soluble solid from a solvent. Whereas filtration, as we have seen, allows you to separate the insoluble solid from the solvent.